Good morning, guys. My name is Akbar. Welcome back to my channel. So today we are going to cover a proper roadmap uh, for your preparation point of view, for your resume point of view, for your interview point of view. What is that set of combination that you need in terms of platform engineering role, or you can say Kubernetes administration after deployment, during deployment? What is that you need apart from CI/CD? So this is like something I've prepared here. You need to cover something in Kubernetes, in OpenShift. So these are the basically two are the tools where you're going to deploy your applications. Okay. OpenShift is a little bit advanced when compared to Kubernetes and compared to Splunk, Dynatrace. These are the monitoring tools. Okay. Now we have to little bit focus on Grafana, Elasticsearch. So my agenda today is to give you a brief walkthrough of Kubernetes concepts and OpenShift concepts along with Grafana, Elasticsearch, Splunk, Dynatrace. So if you are on the way of giving interviews, if you are on the preparation of DevOps, then this video is gonna really helpful to you. Okay. So I've just prepared this. Okay. Production support and monitoring tools. So let's go through the document here. Now, what's Kubernetes basically? I hope you all comfortable with the basics of Kubernetes, right? So let me explain. Kubernetes is a container orchestration platform that automatically deploys, scale, manages containerized application across the cluster. If you have a containerized application, the automation will happen in terms of deployment, in terms of scaling, and in terms of managing the cluster. Everything end-to-end happened in Kubernetes. All these because of Kubernetes. This functionality of deploys, scale, manages everything end-to-end. Now let's understand what is here talking about Kubernetes architecture. So if you look at Kubernetes architecture, what are the main components in master node? What are the main components in worker node? So the basically you can have n number of worker nodes and you can have minimum two master nodes in your real-time environment so that you can handle everything. So master node and worker node. Now let's understand what are the components in master node, what are the components in worker node. If you look at components in master node, these are the components. What is the first component? It is API server. If you look at API server here, what is this API server is going to do? See, this is a basically a front door for the cluster. In Docker, what command you use? Docker to interact with. In Git, what commands we use? Git commands. Pull, push, Git, right? Like that keyword is like in Kubernetes, you use the keyword called kubectl. In Docker, you use Docker, Docker pull, Docker push. Whereas in Git, you use Git, correct? Git pull, Git push, Git commit, like that. So the command when you use kubectl, apply -f or create -f, whatever the commands that you, it will first interact with API server. And API server lies in where? Master node. This is a front door of your cluster. It's a primary contact. Okay. Now what is etcd? Etcd is kind of a database. So it stores the value in terms of key value format. This is the very important one. So the cluster key value brain that stores all the state and configuration. So when I say all the state and configuration, it referring to desired value, current value, all those things. Now, I hope you're clear about API server, right? API server is referring to what? API server is referring, boss, if you have to execute any kind of commands, it has to come to API server first. Before execution, everything API servers check with etcd, which means a database. It will check what kind of scheduling or how to manage, what is this, queue proxy, networking related, all these things. It will check end to end. Okay. Now understand etcd. Etcd means it's kind of a database. It will store the values in a key value pair format, like your name, Rahul, profession, software engineer. Like that, it will share the key value pair format. Now, what is a scheduler? So the name itself is saying decides which worker node a new pod should run on. You cannot run any pod on any node. So the pod has to run on a specific node, then you must have a little bit clarity which pod has to go on which node. So there is some combination of taint and toleration. I'll explain you in upcoming sessions. You need to understand what is a taint and what is a toleration. Pod and a node, taint and toleration. That's how it combination works. So taint and toleration both has to match. Then only that particular pod will go to that specific node. Okay. Now next, controller manager. What is this? Continuously reconcile the actual state with the desired state. So control manager is responsible if something goes wrong with the respective pods. It spin up the new pod. That's all. For example, in a particular node, you have a, imagine you have a 3 nodes. In one particular node, you have some set of pods, and one pod goes down or some XYZ issue, pod got crashed, whatever it is. Control manager will immediately check the information in the etcd database. What is the desired value? What is the current value? If the desired state is 3 pods, then it will, if something goes wrong with one pod, then existing only 2. So it has to spin up another pod. That's the job of controller manager. The controller manager will check based on etcd and then spin up the new pods. Now, what is a kubelet? Now, this guy here, the kubelet is part of a worker node. Now, till now, whatever we have discussed, this API server, controller, and scheduler, API server, etcd, controller, and scheduler. So we have discussed that API server is like a front door of your cluster. kubectl commands talks to it first. Now, etcd is kind of a database. It stores a key value store format. Now, what the scheduler is going to do? Schedule a pod on a node. Now, next, controller manager. What the controller manager is going to do? The actual state with the desired state. Okay. Next, kubelet. What is this kubelet? Kubelet is part of your worker node, not the master node. Now we have completely over with the master node. Now we are discussing everything on a worker node. Understand what's happening here in the worker node. Agent. Agent is really important. Agent is really important in the worker node. The agent on each worker node that starts and stop container as instructed. So this is what it is really important. What it is going to do? It is going to stop and start as instructed. So agent is going to take an action. What is a queue proxy? By the name of a proxy, you should remember network rules to services. Network rules so services can route a traffic to the right pods. I hope it's clear for you. Network rules so services can route a traffic to right pods. Now next, pod versus replica set versus deployment. I hope everything is clear in terms of architecture. There is something called container runtime. Okay, that I will cover it later. So you have an agent, you have a queue proxy, you have a pods, and you have a container runtime as well. That I will cover in upcoming sessions. So when you run kubectl apply-f, this is a command for actual deployments. The API server records the desired state in etcd. The scheduler picks a node and the kubelet on that node pulls the image and start the container. This is what actually happens when you run when you run these kubectl commands. In my previous videos, I've done the lab and everything. Now I'm giving you just a walkthrough so that it will be helpful during interview preparation point of view. Okay. Now, what is happening when you run kubectl apply-f? What is happening here? The API server understand what is your design. I mean, how many number of pods you want in as part of your replicas? How many number of pods you want to maintain on your node? That's what it is. Okay. Desired state in pod. The scheduler picks a node. So desired state, point number one. Point number two, which node on which node the pod has to be scheduled, and the kubelet on that node pulls the image and starts the container. That's how it is. When you run kubectl apply-f, the API server records the desired state. So it will understand what is the desired state and what is on which node it has to schedule. Okay. And kubelet on that node pulls image and start the container. So the job of starting the container, who will take care of it? Kubelet. And scheduling a pod on a node, scheduler. Storing the information in the etcd for a desired state, API server. So like these three components are working in the background as soon as you run this command. I hope this is clear for you. As soon as you run, let me repeat once again, as soon as you run kubectl apply-f, what is that API server is going to do? It's going to store the desired value in etcd, because this is what is really important, because control manager is going to work based on the information which is stored on etcd. And scheduler takes care of where the pod has to schedule, where the pod has to run. And kubelet on that node pulls the image and starts the container. So responsibility of starting the image into the container is kubelet is taking care of. API server is taking care of what is the information that is going to store in etcd. Scheduler is going to take care of the pod is going to schedule on which node. And kubelet is taking care of running the image and converting it to the container. That's what happening as soon as you run the kubectl apply-f. Now, this is a very basic thing of pod, replica set, and deployment. Okay, these are your pods. I hope it's visible now for you. This is your pods. This is your replica set, and this is your deployment. So hierarchy is, this is the smallest unit in Kubernetes. If you do a deployment on a single pod, what will happen? Your application might get crash. So if coming to replica set, which means a duplicate of replica set, how many number of pods you need for an application? If something goes wrong with one pod, the other pods can serve the application. That's the main agenda. So that's why application deployment is not going to happen on a pod. It's going to happen on a replica set. If it is happening on a pod, if this pod goes down, what will happen? Your application get crashed. If the application is getting deployed on a replica set will have a n number of pods. So it's a safe. Now understand pod, replica set, and deployment. So what's a one-line definition to understand? It's the smallest deployable unit, one or more containers sharing the network and storage. One or more containers. Mostly 99% it is only one container, but you can have a multiple containers as well with regards to pod. When you have an image runs into, when you run the image, that particular image will convert into the container. Okay. Now, basically in Docker, we talks about image, whereas here in Kubernetes, we talks in the terms of pods. So let me repeat the small definition here. Smallest deployable unit, one or more containers sharing the network or storage. So if you remember this deployable unit, smallest. So basically in Kubernetes, totally you deal with pods. kubectl get pods. What is a replica set? Ensure a fixed number of identical pod replicas are always running. Ensure a fixed number of identical pod replicas are always running. When I say replica set, if you are going to give the replica set 3, means 3 pods are going to run. If you manage 30, then 30 instances will run. Correct. That's what fixed number of identical pods. Identical pods means same pods. You got it, right? When I say identical pods, it's a Rajinikanth Robo Chitti movie. That's all. Nothing more than that. Deployment. Manages replica sets to enable rolling updates, rollbacks, and versioning. Now, when you refer to a deployment, as I mentioned, deployment should not happen on a pod, it should happen on a replica set. Why? Manages replica set to enabling rolling updates, rollbacks, and versioning. So when the something goes wrong, you can spin up the pod automatically, rolling updates, rolling strategy. When you do a deployment one after another or all together at a time to bring down the pods at a time. So there's a multiple deployment strategies, blue, green, canary, blue, green in terms of environment, canary in terms of users. So that's what we'll be going to cover. So this is what managing replica sets. Because deployment is happening on top of replica sets. So I hope you guys are clear in terms of Kubernetes architecture point of view. We'll go step by step. So the first agenda is Kubernetes. I want you to be familiar with the Kubernetes architecture first before you do something here. So the first point is Kubernetes. And in terms of Kubernetes, we have covered today the Kubernetes architecture. So basically, you have a master node, you have a worker node. What is the API server is going to do? What is the etcd going to do? Scheduler, control manager. API server is a first point of contact for the cluster. If you want to interact with the help of kubectl interact with the API server first to check what is there in etcd, what is the plan as the scheduler, how the controller manager is going to work accordingly, all these things. So it interacts with API server, API servers in the backend, connects to etcd scheduler and works accordingly. Now, when coming to worker node, you have a kubelet which actually starts the images and convert into the container. Kubeproxy talks about networking part, pods and containers. So basically you can have a multiple containers and as preferred industry standard, so one pod will have a one container. You can have a multiple nodes. On each node, you can have a multiple pods. What is your desired and what is the current value? Kubelet plus pod, kubelet plus pod, kubelet plus pod, like this. So this is something basically I've explained you about API server, front door of the cluster, key value pair, it's like a brain, scheduler, which pod has to go to on which node, control manager based on the desired value, it will actually spin up the pods if something goes wrong. Now kubelet is agent. On each, it starts the container as instructed. It starts the container, which means it will run the images. Kubeproxy talks about networking rules. So services can route a traffic to the pods. So basically this is what happening. Important when you look at kubectl apply -f command. If you are going to run this command, what is happening in the backend? In the backend, the API server records the desired state. The API server is work based on the desired state. Now, scheduler picks which pod has to go to which node. Kubelet on that node pulls the image and start the container. It gonna pulls the image and start the container. So the job of kubelet is pulling the image and running the container. Scheduler to make sure on which node your pod is going to schedule, and API server, it talks about APC. So as soon as you run this command, all these things is happening in the backend. So if you are looking into this, pod is the smallest deployable unit. Replica set is the identical pod. As I mentioned, Rajnikant Robo movie Chitti. Similar, all when I say identical, it's all similar. Next, deployment. Deployment is always going to happen not on a individual pods on a replica set. Why? Because there's identical pods. And the deployment has its own deployment strategies. Blue, green, multiple environments will be managed, canary based on users, rolling restart. Rolling, when I say rolling, one after one 25 set of pods, 25% of pods will go down, then other will start like that. This is called a rolling. And recreate. All the pods will go down. There's a downtime for an application and pods will start. kubectl get deployed. Like this. So this is the content for your Kubernetes architecture point of view. We'll discuss the upcoming session about namespace, daemon, stateful set, config map, and secrets. So we'll go step by step, guys. Thanks for watching. Thanks for your time. I'll be coming up with multiple videos to explain these concepts step by step. Thank you very much. Please click on like and subscribe my channel. I really appreciate your support. Thank you. Thanks very much.